All right, so today we are writing quadratic equations. You're going to be able to write quadratics in from vertex form to standard form and standard form back to vertex form. All right, and so when we look at the first little flap, we're going to go from vertex to standard, which actually is a little bit easier. Now we know that standard form is ax squared plus bx plus c, and so if you notice between a vertex form, which we have in this example of y equals parentheses x plus 3 squared minus 5, um, vertex form has parentheses. Standard form doesn't. So to go to vertex form to standard form, we have to get rid of the parentheses. And when you see this expression right here, that basically means, oh, well, that's nothing but x plus 3 times x plus 3, which means we need to go ahead and FOIL that. And that's exactly what you need to do. FOIL that square binomial and then take care of whatever else is there in the problem by doing just simple arithmetic. So this FOILs out to be x squared plus 6x plus 9. So then all we have to do is minus the 5 that was still on the outside here, and then we'll have x squared plus 6x plus 4 as our equation in standard form. Okay? Let's take a look at this one. Now, if there's a number on the outside, okay, a negative, a number, we want to basically treat it as, this is like order of operations, right? We need to apply our exponents before we ever apply our multiplications, which is what a is. A is a -1, and we're multiplying that by that squared expression. So we still need to FOIL that x minus 1 times x minus 1, but after we FOIL that, we need to incorporate the negative and then add 2 at the end. This part will always be at the end no matter what. So when we FOIL x minus 1 times x minus 1, we'll get x squared minus 2x plus 1. And this whole expression, you have to change the sign. So now you apply the negative to it. So it's going to be a negative x squared plus 2x minus 1. And there's still that plus 2 on the outside. So our final expression is negative x squared plus 2x plus 1. Now remember, vertex form and standard form are different ways to write a quadratic. So you should be able to go, your a value in your vertex form should be the same a value in your standard form. And as you can see, it is a negative. All right. And remember, if a is less than 1, that means the parabola opens down and you have a maximum. Okay. Don't forget those different features as well. I want you to try this on your own. When you're ready to see the answer and the work, press play. Hopefully you FOILed x minus 2 to get x squared minus 4x plus 4. And then you multiply this whole expression by the 2 on the outside and then subtracted 3 afterwards. So then it becomes 2x squared minus 8x plus 8. Don't forget to subtract the 3 at the very end and only at the end to get 2x squared minus 8x plus 5 as your final expression. Remember, if a is positive, the parabola opens up, and that point is indeed a minimum. Now to go to standard form to vertex form, you actually have to incorporate the concept of completing the square. Now we talked about completing the square in class a couple of classes ago, but we used it for solving purposes. Okay, when I'm actually trying to go from a standard form to vertex form, I'm just going to need just to do the process of completing the square, not actually solve it. So don't forget, vertex form is a parentheses x minus h squared plus k, remembering that hk represents your vertex. So it's always the opposite of the inside and then the outside. So when you're completing this, when you're writing the equation in vertex form from standard form, like I said, you want to complete the square. And you want to complete the square on the same side, okay? Same rules apply. It needs to be in the form of x squared plus bx, which this problem is. And we know we're trying to fill in this value. Now, in standard form, our c is 0. So what we actually have to do when we're trying to go from standard form to vertex form is we're not just going to complete the square and put the number right beside the bx plus x squared plus bx term. We're actually going to also subtract that value from the c term. So the c term doesn't change. but we're going to subtract whatever we get once we actually complete the square. So remember, the process of completing the square is taking the value of b, which is -6, dividing it by 2, which is -3, and then squaring that value, which is 9. And remember, that number 9 is what turns that x squared minus 6x expression into a perfect square trinomial. But not only do we add 9 here, we're going to subtract 9 over here, and it's always like that. This number we always add, this number we always subtract. So then from there, we'll go ahead and write this as a squared binomial, which is x minus 3 squared. Remember, this number here is always the number we get when we take half of b. So if it's ever a fraction, you know what number it's going to be. And then we just do 0 minus 9, which is minus 9. And that is our equation of y equals x squared minus 6x in vertex form. Y equals parentheses x minus 3 squared minus 9. You can always check by foiling and subtracting 9 to see if you actually get the standard form. What is the vertex for this problem? It would be 3, -9. Is this a max or a min? It is a minimum, because remember, a is greater than 1. And don't forget about the axis of symmetry, which is always the x-coordinate of your vertex, written as an equation. So if I look at this one, remember, I need to be in the form of x squared plus bx, which it is. So I'm going to add what I get when I actually complete the square here, but then subtract over here. Okay? So what's b in this problem? That's right, it's 4. You're going to divide it by 2, which is 2, and then you're going to square it, which is 4. So 4 is the number that goes in the squares. I add it here, but I subtract it here. When I write the first 3 terms as a squared binomial, I'm going to get x plus 2 squared, just like normal. But then over here, I'm going to do 1 minus 4, which is a -3. And here is this quadratic in vertex form. My vertex, -2, -3. And this is indeed a minimum, with an axis of symmetry of x equals -2. So remember, when I'm trying to go from standard form to vertex form, I need to complete the square, making sure that I add here but subtract here. Now you guys do remember that we did have some problems where a was bigger than 1. So in this case, you got to be very careful. You're still going to go through the same process, but you're going to have to do 2 things. The first thing is you're going to have to factor out the a value from the first 2 terms only. Only the first 2 terms. Even if the last term is divisible by a, you want to factor it out of only the first 2 terms. Only the first 2 terms, okay? Now, when we were solving, yes, we divided everything by the a value, but because we're trying to write it in a different form, we cannot lose the a value. The a value in standard form should be the same a value in vertex form. So if we divide it out, we lose it. That's why we factor it out, and we only factor it out of the first 2 terms only. So my a is 5, so I'm going to factor that out. When I factor, it's just like dividing. 5x squared divided by 5 is just x squared. And -10x divided by 5 is a -2x. Remember, you got to take it out of the first 2 terms as well. Then you'll have your plus your number here, and then minus your number here. So that's still the same. Now let's go through the process. Let's complete the square. So I'm going to take b divided by 2, and I'm taking my new b. Because remember, to complete the square, it has to be in the form of x squared plus bx. So I'm using this b right here of -2. I divide that by 2 to get -1. I square it to get 1. Now, here is the other difference when you are trying to go to vertex form and then there's an actual a value. Yes, 1 is going to go here. But in this box, it is going to be the product between the a value and the number you got when you completed the square. And I said product, which means that I'm going to have to take the value of a, which is 5, and multiply it by 1. So it's not going to be a 1 that I'm subtracting, but it's going to be a 5. The number that goes in this box is the value of A times whatever you got when you completed the square. Always, always. So that's the second thing, okay? You have to multiply the value of A and the number you got once you completed the square. After that, it's just like before. We're going to factor. So it's going to be x minus 1 squared, making sure we bring down the 5. And then we're going to do 9 minus 5, which is 4. Okay? So it's two things you got to remember. You got to factor out the value of A from the first two terms only. And then when you're completing the square, the first number is the same, but the last number is what you get when you multiply A by the number you got when you completed the square. Vertex here, 1, 4. It is indeed a max. Nope, I'm sorry, it's not a max, it's a min. And my axis of symmetry is x equals 1. That's it for the foldable, but I want to make sure that you guys have enough practice with writing it in vertex form when A is not 1, okay? I'm going to do this one. Remember, the first thing I need to do is we're going to need to factor out the value of A from the first two terms, which is negative 3. So when I factor out negative 3 from a negative 3x squared, that's going to turn into a x squared, positive now. And then when I factor out a negative 3 from a positive 9x, it's going to give me a negative 3x. Yes, it is going to be a negative 3x. If I wanted to distribute that negative 3 here back through, I should end up with the original problem. So when I factor out a negative, I change the signs. Add here, subtract here. Now I go through the process of completing the square. B is negative 3, so I divide that by 2. That's my B over 2. Now I need to square it. Negative 3 over 2 squared is a 9 over 4. So 9 over 4 goes here, but remember, this is what I get when I do negative 3 times 9 over 4, what you get when you complete the square. That turns into a negative 27 over 4. And if you're like, oh my gosh, fractions, you guys, if you want to use the decimals, that's fine, but you better not round. And if it's a decimal that goes on and on and on forever, then you have to use a fraction. You guys are big boys and girls. You can do fractions. I believe in you. And so now I'm able to write it in my factor form. Negative 3, the A stays the same, so it just gets brought down. Then I have x minus 3 over 2. Remember, this number is always what you get when you take half of B squared. And then I'm going to subtract 10, or I'm going to do negative 10 minus a negative 27 over 4. Remember, two negatives make a positive, so I'm actually going to add here. And this is going to turn into a negative 13 over 4 if I keep it as a fraction. Okay, you can do it as a decimal. It's fine. Vertex is 3 over 2, negative 13 over 4. Okay? That is how you go from standard form to vertex form, and the other problems were how you go from vertex form to standard form. Going from vertex form to standard form, I feel is a lot easier, but you got to know both ways. All right.